Hello and welcome everyone. In today's video, we are going to answer the question, what is machine learning? Machine learning really is the art and science of programming a computer so that it can learn from data. Today, machine learning is everywhere. It is now at the heart of much of the magic in today's high-tech products, ranking your web search results, powering your smartphone's speech recognition, recommending your favorite videos or products, to even beating the world champion at the game AlphaGo. And maybe very soon in the near future, driving your autonomous vehicles as well. Machine learning truly is everywhere. In this video, we are going to take a look at what is machine learning and understand the basic concept at a very high level. If you are new to our channel, then please don't forget to hit the subscribe button and press the bell icon. This really helps support the channel. So without further ado, let's begin. The term machine learning was first coined by Arthur Samuel in 1959 with a more generic definition where he explains machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Later on, a more engineering-oriented one was introduced by Tom Mitchell in 1997, where he calls out a computer program is said to learn from experience E with respect to some task T and some performance measure P, if its performance on T as measured by P improves with experience E. For example, the spam filter is a machine learning program that can learn to flag spam given examples of spam emails and examples of regular emails. The examples that the system uses to learn are called the training set. Each training example is called a training instance. In this case, the task T is to flag spam for new emails, the experience E is the training data, and the performance measure P needs to be defined. For example, you can use the ratio of correctly classified emails. This particular performance measure is called accuracy, and it is often used in classification tasks. If you just download a copy of Wikipedia, your computer has a lot more data, but it is not suddenly better at any tasks. Thus, it is not machine learning. There are numerous definitions that are available today on machine learning. However, at a very broad level, machine learning can be thought of as a subset of the broader field of artificial intelligence, which provides machines with the ability to learn automatically and improve from experience without being explicitly programmed to do so. So to understand this in more detail, let's take a quick look at these two variables, A and B, having a series of different values. Now in this example, B is dependent on the values of A. So when A has the different values of -1, 0, 1, 2, 3 and so on, B takes the values of -3, -1, 1, 3 and 5. Now take a moment, pause the screen and look at the trend of these values and try to answer the question that when the value of A is 4, what is going to be the value of B? Did you answer that? Well, if you answered 7, then you are absolutely correct. But what I want you to do is take a moment here and try to gauge and understand how you really came to the value of 7. If you pay close attention, then I did not provide you with any formula between A and B to figure this out. What exactly is the formula behind this that you were able to predict the number 7? So this is the formula that is behind this. B is equal to 2A minus 1. But how did you actually figure this out? You looked at the different values and the relationship between the two series of numbers in the variables A and B. And you figured out the inherent relationship between these two and figured out the formula, which was B equal to 2A minus 1. This really is what is the essence of machine learning. Machines also learn through these different kinds of examples, pick out the hidden trend in the data and try to figure out a formula or a model based on those examples. So let's now take a quick look at how traditional programming differs from machine learning. So following the very example we just looked at, a few moments ago, what happens in traditional programming is that we provide the program with a set of rules and a set of data. So in our example, we would provide a traditional programming with the formula b equals to 2a minus 1 and the various values of a, as in -1, 0, 1, 2, and so on. Then what the program really does is applies that data on top of those rules and brings us the outputs or the answers in the form of the values of b. In case of machine learning, this is completely different. We provide the machine with the set of data as well as the set of answers, and the machine does exactly what you did a few moments ago. The machine learns from the examples and identifies the inherent relationship between these two sets of data, that is the values of a and the values of b, and then it provides as an output the very equation that we were able to establish a few moments ago as b equals to 2a minus 1. So this is how traditional programming differs from machine learning. Let's now take another very easy example to throw some more light on this topic. Let's say you have been tasked to identify whether a particular fruit is an apple or it's an orange. How would you go about it? This looks relatively simple, but just take a moment to understand. If you were to write a set of instructions that we normally do in terms of traditional programming, how would you go about it? Maybe you will go by color to identify pixel by pixel in these two images that which are the colors that are having the most occurrence. So let's say in case of apple, you will have a dark red in most number of pixels, right? Whereas in the case of orange, you will definitely have orange, the color, as the most number of occurrences in terms of pixels, right? However, if I write this kind of a code and then suddenly another example, I'm given an orange which is a little raw, which has much more greener pixels. In fact, it is entirely green in color. How would my previous code be able to identify this as an orange? It won't be. So I have to go back and change the code, right? And in this way, my code becomes lengthier, and just to identify an orange and apple, I have to write some kind of code which is very, very voluminous like this, right? Now let's take another example. Let's say I go and really do write this kind of a code, but then what happens if my orange is again very dark orange, an example of the previous one that we had taken, but suddenly my apple is now a green apple, right? If I even go and take the burden of writing it again, I may be given many such examples which won't fit these particular examples or these particular instructions. What if both my apple and orange are green? Also, what happens if I'm suddenly being given an image which is grayscale and it's black and white like this? So there could be an innumerable set of permutations and combinations of these images of apples and oranges. How many times are we going to go back and write these kind of instructions again and again, and how efficient that is going to be? This is where we introduce the concept of machine learning. So we provide the machines with different sets of images of apples and oranges and train the machine to identify which are the sets of images that are apples and which are the sets of images that are oranges. The machine learns through these examples, and then in future when it encounters any new image of either an apple or an orange, through its previous learnings out of all these training images, the machine can predict with far more accuracy that what is the probability of that particular fruit being an apple or an orange. This typically is an example of a supervised machine learning algorithm, which we will take a look at far more detail in subsequent videos. But I hope at a very high level, this example was able to clarify the concept of machine learning. So with that, we come to the conclusion of this episode where we tried to explain what is machine learning from a very high level point of view. If you like our videos and feel that this is in any way helpful to your machine learning, artificial intelligence, and data science journey, then please like, share, and subscribe to our channel. This really motivates and encourages us to bring more meaningful and useful videos to you. Thanks a lot. Keep watching.